Hi, this is a basic arithmetic video on indices. We'll have a look at a whole range of examples of how the indices work. Okay, to simplify x squared multiplied by x to the 6, this is a classic example of when you're multiplying terms with indices, you get to add the indices. So it's just x to the 2 plus 6, or x to the 8 would be our final answer. We just add the indices there. When we're dividing terms with indices, we subtract the indices, so it's just a to the power of 6 minus 2, or a to the 4. Subtract the indices. Here, when you've got a power being put to another power, we multiply the indices there. M to the power of 6 times 5, or m to the 30. In this one, the front numbers multiply normally, so just 3 times 4 equals 12 for the front number. That's just acting like normal numbers there. And then we kick in that rule whereby when we're multiplying terms with indices, we add the indices. So we add the indices on the x's and we get x to the 7. So 12x to the 7. Kind of like two questions in one. We just do the multiplication for the front numbers and then we add the indices for the second bit. Here we just divide the numbers, the front numbers normally, so 9 goes into 27 3 times. And then we subtract the indices, so on the a bits it's a to the 12 divided by a to the 2, but we'd do 12 minus 2. So we'd end up with 3a to the 10 there. The front numbers work normally, just dividing 9 into 27 going 3 times, and we'd subtract the indices because we're dividing. Here, you'll notice the 3 is inside the brackets and everything in the brackets is getting squared. So we'd square that 3 and make 9. And then we'd kick in that rule that says we multiply the indices. So it'll be y to the 8. Now that makes sense if you think about it this other way as well. We could write that out as 3y to the 4 multiplied by itself, because that's what squaring is, isn't it? We're multiplying whatever's in the being squared by itself, and then that would lead to 9 out the front. Then we'd add the indices and get the same answer as we did before. So whichever way we think about it, we'll still get 9y to the 8. Here, when a fraction is being put to a power, that power acts on the top of the fraction and on the bottom. It sort of gets distributed between the two bits of the fraction there. So it's really two questions in one, and because you've got a power of a power there, we're multiplying the indices each time. So it's a to the power of 5 times 3, or 15, and on the bottom it's b to the power of 4 times 3, which is 12. Okay, so the top and the bottom gets acted on by that cube. Alright, interesting one here. We'll do a bit of simplifying first, because you'll notice there's an m squared on the top and an m to the power of 5 on the bottom. So let's think of that separately just over here. M squared on the top is really m times m over m times m times m times m times m. Now let me just get a different color to my pen and do a bit of cancelling out here. We can find something that goes into the top and bottom here. I'm just showing you how we are simplifying the m section here. M can divide into the top once and into the bottom once, in the top once and into the bottom once, and we're left with 1 over m cubed in this situation. So rather than having a m squared on the top and an m to the 5 on the bottom, let's simplify it to be 1 over m cubed for the m section. We've still got that n to the 4 on the top. So that kind of leads us to have just n to the 4 on top over m cubed. And that's just slightly simpler version before we substitute in 1/3 wherever there's an m and 2/5 wherever there's an n. So we've simplified that expression a little bit. Now we'll evaluate it. Anytime there's an n, we're going to put a 2/5. So really we end up with, on the top, 2/5, and that's getting put to the power of 4 over Now m is getting cubed, and m is going to be replaced by a 1/3 there. 1/3, and that's getting cubed. Alright, now on a previous question we saw that a fraction being put to a power has that power acting on the top and the bottom. So we've got 2 to the power of 4 over 5 to the power of 4 being divided by 1 cubed over 3 cubed. Quite a question, this one. Then we are perhaps typing that into our calculator. And one thing we could do is 2 to the power of 4 over 5 to the power of 4, and when we're dividing by a fraction we turn it upside down and multiply. So we could turn that upside down and have 3 cubed over 1 cubed, etc. But at some stage there we'll put it into our calculator. 432, if we type that in carefully, over 625. And we could type that in and make sure that's the simplest answer there. So we saw a bit of cancelling down with the m's, and don't be afraid, don't be too proud to do this sort of a thing when you're not sure about how an index is going to simplify. Write it out if it's not too big, and this sort of illustrates how the things work. With an m squared on the top and an m to the 5 on the bottom ends up sort of cancelling out and ending up with still having an m to the 3 on the bottom. And being careful with your fractions with your calculator. Interesting question. Okay, 5 to the minus 4 as a fraction. Now a negative indice, what it does is turns things upside down, particularly if they're in fraction form. So we could put any fraction, or any, pardon me, any whole number over 1, and putting that to the minus 4, what that does is turns that upside down, so you get 1 over 5 to the power of 4. Now 1 over 5 to the 4, that's 5 times 5 times 5 times 5, and I'm here to tell you that's 1 over 625. So a negative indice takes the fraction version of whatever is there and turns it upside down, and that power goes along wherever that 5 is. So this is a combination of that turning upside down type rule for a negative indice, and that rule that says the power actually acts on the top and the bottom of a fraction when it's out the top there. So we'll turn that upside down, 4 over 3, and we'll put the cube on the top and the bottom. It kind of distributes through. Now 4 to the power of 3 is 64, because it's 4 times 4 times 4. And 3 cubed is 27, if we just wanted to write it as an improper fraction there. So the negative indice turned it upside down, and that cubic power, the cube, acts on the top and the bottom as well. Okay, we've got a lot of negative indices here. We could write it all out separately, but what happens is any negative indice on the top ends up on the bottom. Any negative indice on the bottom ends up on the top. So if that a to the minus 2 went down the bottom and lost its minus, and these b's down the bottom kind of use up the negative by becoming a top number. B cubed on the top and c to the 5. Kind of interesting, but you kind of use up any negative indice by once you turn that thing upside down. So yeah, separately, a to the minus 2 ends up being 1 over a squared. 1 over, if it's already underneath there, negative 3 turns out to be a b cubed on top, and we don't need to write the over 1 bit. And c to the minus 5 on the bottom ends up being a c to the 5 on top, and we won't worry about writing the over 1 bit on the bottom of those last two. So that's separately, just to show you that that occurred. We're really turning it upside down and using up the negative indices by doing that. Here we've got to be careful. There's no bracket around the 6 and the a, so it's 6 separately multiplying with a to the minus 2. And by having that 6 separate, we don't make the mistake of turning it upside down as well. So we've got a 6 times, now a to the minus 2 is 1 over a squared, because they want us to write it without any negative indices. We could also put that over 1 to help our brain a little bit. And we'll see when we multiply across the top and across the bottom that we have a 6 on the top over an a squared. And that's kind of reflecting the fact that 6 is a normal 6 over 1, and it didn't get affected by that negative indice up there because there wasn't any brackets around it. So that 6 is separate. So we end up with 6 over a squared there. Alright, we've got a whole bracket there to the minus 8, and all they want us to do is to write it without any negative indices. They don't need us to simplify it or anything like that. So we'll just take that, think of it as being over 1 originally, and use up that negative indice by turning that fraction version upside down. So we'll get equals 1 over, in brackets, 7m plus 4 just to the power of 8. So see how we've used up that minus once we've turned it upside down. So that's an interesting one. We use up a negative indice when we turn it upside down from fraction form. Anything to the power of 0 equals 1. We can have a bit of an illustration of that by a lot of different means, but I'll just remind you of that rule. We won't have to go into it and reteach you that whole thing. A to the power of 0 equals 1. Now, a slight variation there which illustrates again the fact that this isn't put in brackets here. This is a 5 times by an a to the 0. So this bit here ends up being 1, but that 5 isn't getting put to the power of 0, so it's got to be kept separately. 5 times something that's 1, this section here is equal to 1. So we've still got a 5 there. Be different if we had brackets around it, which we might see in a future question. But I've got to be a little careful there. Not everything with a 0 indice, not every question with a 0 indice in it ends up being 1 for the answer. Got to keep our wits about us. This is the one I was talking about that might be coming up soon. Both the 7 and the a are being put to the power of 0, so we get 1 for that. That 7 isn't separate, it's getting acted upon by a power of 0, and they all turn into 1 all the time. Be a little careful there. If we want to convert 1 over x to the 7 in pure index form, it's a bit of fraction form at the moment, we could have x to the minus 7, and that's just a simple index form, it's just a 1 term. So turning that upside down creates a negative indice there. Now fractional indices, m to the 3/4, I'll write this a bit bigger. What happens is the top is the power, and the bottom number is how much it is getting rooted. The power and the root. There's one way to remember this. It's kind of a funny way, but now you'll check out how poorly I can draw here. If this is a flower, and we use the word flower power, which is a common expression, the top, the part that you see of a flower is the power bit. It's a powerful, pretty thing. And what happens underneath the ground? There's the roots. So flower power, the top bit is the power, and underneath there is the root. So the bottom of the fraction is the root section. So what I'm getting at here is we can write this as the 4th root, that takes care of the bottom bit, of m cubed. So we've still got the power of 3 there, and the root out the front there is the 4th root of m cubed. So remember that flower power. This one's got a lot going on here. We've got a minus, and we don't want any fractional indices here, and we could also have some non-negative indices as well. If we wanted to use up the minus bit, we'd put it under 1, and once again we'd have a 4th root of m cubed. Oops, n cubed. Read the question carefully, Mr. Blake. That's an n. Did a bit of colouring in there. N cubed. So the top is the power, the bottom is the root, and the minus turns it upside down. Anything without a fraction version could be put as over 1, couldn't it? So that's turned upside down, put to the power of 3, and 4th rooted. The index form of a square root, you may remember, is a to the half. That's the square root of a to the power of half. Cube root is to the power of 1/3. b to the 1/3 is a cube root. Now here we've got a combination of a power of 3, remember the power section of a fractional indices on the top, and a square root. So we'll call that x to the power of 3 over 2. It's being put to the power of 3 on the top of the fraction, and the bottom of the fraction is the root section, square rooted. So x to the 3 on 2. Alright, now this is under 1, so if we took away that fraction version really, we could write it in index form. This is going the other direction here. We've got y, and we've got it to the power of a negative, because it was an upside down one, under 1 there. And the power is the 4, so he'll be the top number of our fractional indices, and it's a cube root. So y to the minus 4 on 3. Okay, that ran through quite a lot of examples of indices. Hope that helps. It's good to know a little bit about each of those and be careful about some of those variations. All the best with your studies. peterblakemaths.com